Welcome. In this video, we will show how to use the 400 series configuration software to create a program job file that can be loaded into the control panel. The 400 series configurator application is used to program the 400 series addressable control panels. While this can be viewed on its own, it could also be helpful to follow along with the video's instructional segments. The configuration utility can be downloaded through links found in the video description below. When the 400 series configuration utility is first installed, the user preferences options are presented. These options include selecting the serial port your computer will use to connect to the panel. These options can be changed later under the File menu. This slide details the File menu of the 400 series configurator utility with functions for database management, user preferences, and printing. Options include backing up and restoring the database, compacting it for performance, setting user preferences, and managing print jobs. The utility provides a straightforward interface for maintaining and managing the system's database and user settings. The Job menu within the 400 series configurator utility. The menu includes options to create, open, import, export, and manage different versions of jobs, which are the database files configured in the software and sent to the panel. It provides functionalities for job validation, conversion between models, and comparison of job versions, facilitating efficient management of fire alarm system configurations. The Insert menu allows users to add various components to a fire alarm system configuration job. Options include adding loop controllers, display adders, devices, groups, and correlations. Some commands may be unavailable depending on the context within the user interface. For additional contextual options, right-clicking in different areas of the configurator provides shortcut options. The Edit menu contains commands for managing items within the software. It includes options to delete, modify, copy, and paste items. The commands are accessible through keyboard shortcuts. The availability of these commands depends on the user's current selection in the interface. To check the version of the 400 series configurator utility, open the software. Navigate to the top menu bar. Click on the Help menu, typically located at the far right of the menu bar. In the drop-down menu that appears, select About. A pop-up window will display the version number of the software and the database version, along with the date and time of the last update. The 400 series configurator is a software utility that facilitates programming for both the MR401 and MR400 fire alarm control panels. These panels share a common configurator utility, which simplifies programming tasks. To create a new job in the 400 series configurator utility, follow these steps. Select Job from the top menu, then choose New Job, or use the keyboard shortcut Ctrl+N to open the Create Job dialog. In the dialog, enter the name of the job in the provided field. You must also enter details in the comments section, which is mandatory. From the drop-down menu, select the appropriate model number of the control panel for your project. In this case, select 401. After filling in the necessary details, click OK to proceed with creating the new job. The Job Details view of the 400 series configurator utility is displayed when Job Details is selected from the job tree on the left side of the interface. This job tree allows you to configure various elements of the panel hardware and circuits. By expanding the nodes of the tree, you can access additional items for configuration. The main window shows options for enabling items like manual signal silence and fire drill, along with operational modes such as positive alarm sequence. It also provides settings for evacuation codes and agency selection, as well as various other options to tailor the panel's operation to specific requirements. Each option is described further in the Help utility. In the Job Details Options section of the 400 series configurator utility, you can enable the signal silence and fire drill functions on the control panel. Additionally, you can set the synchronization protocol for signaling devices connected to the onboard notification appliance circuits. For these devices to function correctly with the sync feature, they must be configured as strobe type within the NAC settings. Users can also specify the strobe type from a drop-down menu that includes options such as Mercom, Gentex, WeLock, and System Sensor. There are other configurable options available, which are detailed in the help dialog or the installation manual. These include settings for auxiliary disconnects, positive alarm sequence, and Class A loops. Setting up NAC circuits in the 400 series configurator utility. Select Loop 0, hardwired from the job tree. This represents the panel's onboard notification appliance circuits. To configure for synchronized audible and visual devices, change the type to strobe by double-clicking the cell and selecting from the drop-down. Label each circuit for identification using the tag line 1 and tag line 2 cells, providing custom text that describes the location or function of the circuit. Edit these by double-clicking each cell and typing the relevant information. This step should be repeated for each circuit listed. To add addressable devices to Loop 1, select Loop 1 from the job tree, which represents the onboard addressable loop circuit. Right-click in the blank area of the Loop 1 section to bring up the contextual menu for adding devices. From the menu, choose Add Device to initiate the process of adding a new device to this loop. After selecting Add Device from the contextual menu in Loop 1, the Add Device dialog box will appear. This is where you can specify the type of device, its address, and the number of devices you want to add to this loop, and other options depending on the device selected. In the Add Devices dialog, you can select from various device types by clicking on the Type drop-down menu. Choose the smoke sensor, Photo 4010, from the device models available. Referring to the respective datasheets and installation manuals is recommended for detailed information on each device type. In the Add Devices dialog for Loop 1, after selecting the device type, you can choose the appropriate mounting base type from the Options drop-down menu. For this example, select NAB non-addressable base as the standard mounting base. This selection corresponds with the chosen device type and is necessary for proper installation and operation. After choosing the device type and mounting base, you can specify how the device should be processed by selecting from the Process As drop-down menu. Choose Alarm Input for devices that should trigger an alarm state. The installation manual or the help menu has more details on process types and their implications for system behavior. In the Add Devices dialog for Loop 1, you can assign an address to your device by selecting from the Address drop-down menu. The configurator automatically suggests the first available address, but you can choose any unused address. For devices with multiple sub-address points, they will be designated as subsequent numbers like 1.2, 1.3, and so forth. Select the default address of 1. Once assigned, addresses can be adjusted later if needed. You have the option to specify the number of devices you want to add. Here, change the quantity to add 6 smoke detectors. Upon confirming the addition by clicking Add, these devices will populate in the system, starting from the first available address, and continue sequentially. This feature is useful for efficiently adding multiple devices of the same type to your configuration. After adding the photo smoke detectors to Loop 1, the configuration process continues with the addition of a dual input module. This is selected by changing the device type to dual input 4040 and setting the option to Class B. The process is defined as alarm input. Only one device of this type is being added at this point, so the number to add is adjusted to 1. After setting these parameters, clicking Add will include this module in the system configuration. The dual input module is set with a Class B option, providing 2 input addresses under one base address. Here, the base address is 7.1, with 7.1 as the physical primary input address, and 7.2 as the sub-addressed input. This configuration means that although 2 separate inputs are programmable, they occupy a single physical address on Loop 1. An addressable manual pull station uses the dual input mini module type, factory installed and wired as Class A. The following settings are used in the configuration. The device type is set as dual input 4040-4041. The wiring option selected is Class A. The device is set to be processed as alarm input. The number to be added is specified as 1. After these selections, click Add to include the manual pull station in the system configuration. When you add any dual input module with a Class A option, it's assigned a single address, which in this case is 8.1. The options column indicates the wiring type as Class A, and the F3 column reflects this with a CA label, signifying that it is set up in the Class A wiring style. This device will occupy one physical address on the loop and enables the connection of a device, such as an addressable manual pull station, that is factory wired as Class A. To add a relay module, select Dual Relay 4045 as the device type. Set the process type to Relay and enter 1 in the Number to Add field. After setting these parameters, click on the Add button to include the relay module in your configuration. This will add the relay module to the primary address 9.1 on the loop. Adding a dual relay module results in a device that has a sub-address. This means each of the module's 2 relay contacts can be controlled independently, though they share a single physical address. Such a setup is particularly useful for applications like elevator recall, where primary and alternate functions can be managed by a single device. Address 9.1 is the main address and can be set as the primary recall relay contact, and 9.2 serves as the sub-address for the second relay contact that can be programmed for the alternate floor signal. This results in a single device used for elevator control signals. Adding a dual sensor with an addressable relay base will create 3 addressable points linked to one primary address. To add this device, select Photo 135 4020 as the type, which is a photoelectric smoke sensor with a 135 degrees Fahrenheit fixed temperature heat sensor. For options, choose ARB addressable relay base, indicating an addressable relay base. Set the process as to alarm input. Enter 1 for the number to add and click on Add. The device will be added with the primary address of 10.1. When adding a dual sensor with an addressable relay base to the system, a single device with 3 programmable points is created. In this configuration, the primary address 10.1 is assigned to the photo smoke sensor. The sub-address 10.2 is designated for the 135 degrees Fahrenheit fixed temperature heat sensor. The addressable relay base is given address 10.3. Each of these points is programmable independently but share one physical device location and occupies a single physical address on loop 1. This efficient use of addresses allows for a streamlined and organized configuration of the system's components. We have a small system with 14 points programmed using 10 physical loop addresses. This is not a real project, but used to demonstrate basic workflows and functionalities. Let's move on with the actual programming. We will be adding tags, device labels that are displayed on the LCD, then correlations, the term used for programming, or linking inputs and outputs together. Some fields can be modified by double-clicking in the cell and choosing the options from the options that are available. The F columns, flags, can be set to define certain functions depending on the device type. Some of these are NS, non-silenceable, CA, Class A, NF, no flash device LED, and others. Refer to the help file for more details. Next, let's edit the tags for each device first. Edit the device tags to match what is shown in the video. You may want to pause the video to complete this operation. When you have completed adding the tag information, see if you can spot an issue with one of the device's type setting. We need to adjust the device type for the valve tamper device to be a non-latching supervisory instead of the default selection of alarm input. Double-click the cell to modify its selection and choose non-latch supervisory. Adding correlations refers to programming relationships between input devices like smoke detectors or input modules and output functions such as alarms or relays. This step is crucial for creating a responsive alarm system. Correlations can be configured in two ways: by setting inputs to activate specific outputs or by selecting an output to be triggered by designated inputs. The latter approach can be more efficient, as it often involves fewer steps due to systems typically having more inputs than outputs. The following will show examples of each. To correlate devices, right-click on the device you wish to modify, in this case the first smoke detector in our job, and select the Add Correlations option. The correlation dialog opens. This window shows all circuits and devices that are available to be correlated to the device we selected. There are 4 tabs: Signal, Relay, Display, and Output zones. The smoke detector we right-clicked on will be correlated to activate all 4 NAC circuits. Click on the NAC Floor 1 circuit and click Add. You can also double-click to add it directly. The NAC Floor 1 circuit is removed from the selection area and now shows as a correlated circuit in the Correlations window. The Correlations window shows the correlations for the currently selected device, Smoke Detector Floor 1 Electric Room. Let's add the other NAC circuits to this device. We can add multiple selections at the same time. Hold Ctrl and left-click to select each of the remaining circuits. When the circuits are highlighted, click on Add, then close the dialog. When a device is selected, the Correlations Details area will display associated correlations in the Correlations window. Here we can see the first smoke detector has now been correlated to all 4 NACs. Deleting a correlation is done by editing the correlated devices in the Correlations window. Selecting a device in the Details area shows its correlations below. In the Correlations window, right-click on a correlation and select Delete to remove it. You can also select it and press Delete on your keyboard. Let's remove NAC Floor 4. Next, let's program the Floor 1 Elevator Lobby Smoke Detector. Right-click on the next device, Smoke Detector Floor 1 Elevator Lobby, and select Add Correlations. We will add 3 of the NACs by holding Ctrl and selecting the circuits we want. Then click on Add. We also want to add the alternate floor recall relay, since this is the Floor 1 Elevator Lobby Smoke Detector. Selecting the Relay tab shows relays that can also be correlated. Select the Elevator Recall Alternate Relay and add it to the device's correlations. After we close the dialog, we can see the correlations by clicking on the tabs in the Correlations Details area. Notice that the tabs are highlighted in blue when they contain devices or circuits. We have now correlated 2 smoke detectors to the onboard notification appliance circuits. Let's look at the NACs directly and view what has been correlated to them. Select Loop 0 to view the NACs. We can select a NAC in the Device Details area and view the input devices or circuits that are activating it by looking in the Correlations window. This can be helpful to verify what devices or circuits have been correlated to an output such as a NAC or relay. We can also work with output circuits like NACs and relays by directly correlating inputs to them. Let's look at this next. Right-clicking on a NAC or relay also allows for adding correlations. In this case, the devices allowed will be input-type devices. We can select and add the alarm input devices from the correlation dialog. We can also select multiple circuits to add correlations at the same time. Here, we select NAC 2 and NAC 3 and add all the alarm inputs at one time. This is an easy way to configure your job. By directly correlating inputs to your outputs, NACs, relays, etc., you can quickly program your system instead of correlating each individual input device. Generally, there are more input devices on a system. By going directly to the output circuits and correlating inputs can reduce the time needed to program the entire system. Now, go back to addressable loop 1. We can look through the alarm input devices and see they have been correlated to all of the NACs. We did this on the previous step by correlating the notification appliance circuits to the alarm device inputs directly. Moving on, we haven't correlated the primary recall relay yet. Let's do that next. Select the relay for primary recall and right-click to add correlations. Since this is an output device, we will see input devices that can be correlated. Let's add the second and third floor elevator lobby smoke detectors. We can then review our correlations for each device by highlighting and checking the correlations window to confirm everything is looking good. Lastly, let's configure the elevator machine room smoke sensor, heat sensor, and relay base. We configure the smoke detector to activate the primary recall relay. Next, we configure the heat detector to activate the addressable relay base to provide a shunt trip signal. We can also add a 45-second delay to the shunt trip relay activation, allowing time for the elevator to reach the primary landing before triggering a power shunt operation. All of these programmable points exist only using one physical address on the loop and one physical device location. Let's look at creating bypass groups. These can be used to provide a temporary bypass of circuits and devices. Once a bypass group has been created, it can be activated using the panel's main LCD menu options or correlated to a programmable button. When a bypass group is activated, the correlated devices and/or circuits are bypassed and will not be activated. Here, we are creating bypass groups for the notification appliance circuits and elevator control relays. To create a bypass group, select Bypass Groups in the job tree, right-click in the blank area, select Add Group, give the new group a name, and correlate the desired devices and circuits. To set up the built-in UDAC dialer for your fire alarm system, access the dialer configuration panel by selecting it from the job tree. Here, you can program the dialer settings to ensure communication with the central monitoring station via a telephone line. Enter the account and telephone numbers in the designated fields. Configure the report format as required by the monitoring service. Common formats include Contact ID and SIA. Adjust the timers and dialer settings, including line retries. Verify all settings, especially the Enable checkbox, to activate the dialer. For comprehensive guidance, consult the panel installation manual, which provides specific instructions and important considerations for your system model and monitoring requirements. If you encounter any issues or need additional assistance, you can access the help documentation within the software or in the configuration guide and manuals. Let's look at adding annunciators. To add an annunciator, right-click on the Job Details item and select Add Annunciator. Select the type of annunciator that will be installed and click on Add. The Annunciator Node section of the job tree is now added. Each added annunciator will now show in the RAM 3500 node tree section when expanded. The annunciators can be tagged with a location for reference. Installed annunciators need to be addressed and correspond with the addresses set here in the configuration. To expand the capabilities of the MR401 panel to have 3 addressable loops in total, a 2-loop controller module can be added. To add additional loops, right-click on the base I/O item in the job tree and select Add Loop Controllers from the context menu. This action will allow for the configuration of additional loops and enhance the panel's capacity to monitor and control more devices. Devices for Loop 2 and Loop 3 can be added and configured in the same manner as we did for the built-in Loop 1. This expansion allows for a broader range of device management and system customization, enabling it to address more complex fire alarm system requirements. The MR401 has 2 available positions for adding either 48 LED display adders or 24-button display adders, allowing for greater flexibility and control within the system. To insert these display adders, right-click on the main display in the job tree on the left side of the configurator utility. Then, from the drop-down menu, select Add Display Adder. This will initiate the process of integrating additional display units into the system, expanding the visual feedback capabilities of the fire control panel. Upon selection, the Select Adder Type dialog box appears. Here, you can choose the type of adder you wish to add by clicking on the Add button. Remember, the system allows a maximum of 2 display adders to be added. When a RAX 1048 is integrated into the job, you can specify the type of LED required for different statuses, such as a system LED, input, output, and bypass. These correlate to internal statuses, input circuit statuses, output statuses, and bypass group statuses, respectively. For example, to assign an LED to input devices, select IPT zone and select the desired assignment like alarm, supervisory, and so on. Then, tag the LEDs as needed. Correlations are made to the LED by right-clicking and adding correlations to the LED circuit. The job configuration is now complete. Congratulations, you have learned the basics for working with the 400 series configurator utility. To connect and send a job to your panel, follow the detailed instructions in the installation and configuration guide manuals. Thanks for watching. For additional resources and information, visit Secutron.com. Also, additional resources can be found in the video description below.